Now, let's look at indicators. We've used an indicator, but we really haven't talked very much about what they are. We use indicators for a visual indication of when we have reached our equivalence point. But remember, we made a distinction between the equivalence point is the actual stoichiometric neutralization. We have equal amounts of our acid and base. They've neutralized each other. That's the equivalence point. The end point is where our indicator tells us to stop the titration. The goal of choosing an indicator is to have your end point be as close to your equivalence point as possible. So basically, indicators are weak acids that change color when they are forming their conjugate base. Okay, so HIN, this is some weak acid that is our indicator. IN would be the conjugate base of it. And so basically an indicator is something where the acid and the conjugate base are different colors in solution. Okay, so let's look here. This is a table. You should have a similar table in your book, but it shows you some common indicators, what their colors are, and what the pH range for them for when they change, when they start to change color. This is the range over which you will see the change from the acid color to the base color. Okay, and the rule of thumb is that for the acidic color, like we will see the color that the acid forms in solution, we will see that when the acid to base ratio is greater than or equal to 10. Okay, so as long as you have at least 10 times more of the acid than you do of the base, you're going to see the color of the acid. And then the same thing here, if it's less than that, you're going to see the color of the conjugate base. Or conversely, if the base is present in at least a tenth of it, you're going to see that the base color. So here's a strong acid, strong base titration curve, and this is kind of showing you why we use phenolphthalein as a common indicator for this type of titration. And if you look, all right, strong acid, strong base, there is our pH of 7. All right, so that's where we are wanting to see the change. Well, our methyl red, it's going to change almost too soon right there. But look at what's going on with the phenolphthalein. Granted, it's going to change up here at a pH of 10. But when you look at this curve, all right, look at what is the volume difference in our titrant. Not a whole lot. Okay, and so that's why it's okay to use phenolphthalein, because in a strong acid, strong base titration, the pH changes so dramatically at the equivalence point that it's okay to use, that we'll get a good indication of our equivalence point with that indicator. All right, so let's look here. How would we decide then? Say we're going to titrate the nitrous acid, weak acid with a strong base. All right, so at the equivalence point, it's going to have the conjugate base, so it'll be, the pH will be greater than 7 at the equivalence point. And so if we look there, if it's going to be above 7, here we have, this one has a nice change in there, right in that area. And then also phenolphthalein, we're going to get, probably the creosol red might be a little better. What you'd have to do is look at the, look at what range you would have based on the concentration that you're using, etc., to see where your pH was going to fall at that point, at the equivalence point. but either of those will give you a nice range in there.